My name is Scott Pack. This is Attacking AWS Beyond Security Groups, so we're going to be getting into it. First off, does anybody recognize this picture? We've got a couple. All right, so there's some Destiny 2 goodness sprinkled through this presentation. I have a pretty bad history of choosing selfies to put in these talks, so I avoided that problem altogether. A little background on myself. I'm a security engineer at Adobe. I've been working in AWS or on AWS stuff for about 3 years now. I love automating things. I spend a good chunk of most days writing Python to do something for me so that I never have to think about it or worry about it again. I've been playing far too much Destiny over the past month. So overview of what we're going to be covering is the AWS control and data planes, the authentication flows that allow calls to be made and changes to be made in both of those environments, a little bit about how to do Recon on permissions, pivoting in AWS from the control plane to the data plane and vice versa. And then, assuming we have time for it, and I think we probably will, we'll get into scaling security assessments and persisting access and a couple other fun tools. So the control plane. AWS, like most cloud providers, like to break up their services into a couple different families. They have their SaaS, their PaaS, and their IaaS, but for most things, you can divide them up into either control plane or data plane. If you are making calls directly to the provider's APIs, like EC2 client run instances, or listing buckets, or creating hosted zones in their managed DNS, you are probably working against their control plane. In that case, you're using their authentication mechanisms. If you are making requests against a web application that you are running on Nginx or something on your instances, that's the data plane. So that will be traffic flowing through the VPCs, hitting instances, contents of your RDS or your managed database instances, SSL termination. That's all stuff that you handle. In the AWS and Azure managed security shared responsibility model, that's stuff that you are responsible for taking care of. The cloud providers ensure that the security of their APIs is in place. The account owners are responsible for maintaining the security of the infrastructure that is hosted on top of that. So AWS authentication. This is pretty much what all auth boils down to on the control plane. There are two types of entities that can be set up in IAM that represent people or that you can tie permissions to. Those are IAM users. An IAM user can either be a human that is authenticating to the AWS console, the UI, or it could be representing a service. So if you're running like an automated system that is talking with these APIs like Terraform, those are represented in AWS as an IAM user. IAM users can be granted a console password and optionally MFA. Both of those are actually optional. If a user exists but does not have a console password, they won't be able to get into the UI. IAM users can also be given up to 2 API keys, which is an access key ID and an access secret. Root credentials are also a thing. Those are not actually IAM resources, however. So it's a different handful of calls that are used to manipulate those. Roles are kind of an interesting beast in AWS. Rather than being like a collection of permissions which you can tag to a user, a role is kind of an ephemeral identity that has a trust policy. So if I am tied to the role through a trust policy as a principal, I can log in as myself, as Scott, and then assume a role that is either in the same account or even in a different AWS account and start making calls with the permissions that that role has rather than making calls with my own permissions. Other ways that you can set up a principal is obviously an IAM user. You can also set a principal to be a different role, an IP address, a service ID. So when AWS does things within your account, usually they're using an IAM role to get those permissions. Yeah, I mentioned STS assume role. That's how you get the temporary credentials from that role. Interesting thing about STS credentials, which are those temporary credentials given to you when you assume the role, For the most part, they look exactly like normal API credentials. You have a key ID and a key secret. You also get an access token, which you have to include with those requests. So when you make calls against the AWS APIs, I think it's pretty cool the way they've got this set up. Most of the APIs that I had worked with before AWS had basically a shared secret. So you would go into the tool, you would create a user, you would say generate a key, and it would store the key on, well, not even a key, store the password on its side, and it would give you the password. When you made a request to the service, you would either include that as part of your GET or POST, or you would put it into an HTTP authorization header or basic auth. For AWS, it's a little bit more interesting. When you request credentials through IAM in AWS, you are given a private key. So that is part of the private, it's the private half of an asymmetric encryption process. So you have your secret key. When you make calls against AWS, you, or more likely your client, will form the request. It will add a couple things like the date stamp and the region, the service you're calling, and then it will hash that. It will encrypt it with your private key, so it's signing your request, and then it will send that off to AWS. What that means is that they, after giving you your private key, no longer have, they don't need to have that anymore. So that's one of the reasons that if you lose your API credentials, support's not going to be able to help you out there. They don't keep that private key after it's been given to you. So the signature, once you've generated it, is added to the HTTP authorization or a GET parameter, but just the signature. So it's not putting that whole key and passing that back and forth with each request. So if you're using a role or a user, you're always going to be using the key ID and the key secret. If you're using a role, you will also need that session token. So most of the AWS tools that you'll use to interact with the APIs, like CLI or Boto3, I think there's SDKs for probably like 8 or 9 different languages, all automate that whole signing process for you. And there's a couple different ways that you can set up the credentials. You can either specify them. So the first step, the first way that most tools will look for it is if you pass the credentials in right at the command at that time. So if you're on the AWS CLI and you say AWS S3 list buckets, you can give a hyphen AWS secret access key equals whatever, AWS secret access ID equals whatever. So that's first preference. The next place the tools will look is in the environment. So it'll look for environment variables with those access key ID and secret names, and pull those in and use those. Next, it will look for a configuration file, which is .aws credentials in your home directory. You can also set up multiple profiles there. So if you have a handful of different AWS accounts that you're using, you can create like account 1, account 2, account 3, and then whenever you make a call, you can specify in AWS CLI, tac profile equals account 1 or 3 or whatever. There is a default, so if you don't specify any, it will just fail back to that default. Yeah, so they're specified right there like that. And then the last one, which is pretty interesting, is only used in EC2. With EC2 in AWS, every instance is kicked with a little HTTP sidecar service that is only accessible by that EC2 instance. They call that the metadata service. If you make a request to 169.254, 169.254, you can browse through that directory structure and you can get information about the host. So what that's used for is when a host is kicked, it runs a cloud init script that pulls down this metadata and then assigns that into the appropriate places on the instance. So if you've wondered in the past, like how does my public key get onto this AWS instance when I kick it? The sidecar service is brought up, it is populated with your SSH public key. Then when the instance comes up, that cloud init program pulls a specific directory, a specific file where it knows SSH public keys will be, and then we'll cat that into your authorized keys file in your home directory. Additionally, role information will be stored here. So if you attach an IAM role to an instance, temporary credentials will be set and then rotated in this metadata service. So the CLI and Boto3 utilities know that if it doesn't find credentials in preferences 1, 2, and 3, it can look in the metadata service to see if there's a role that's been configured and attached to that instance. So some attack surfaces. Most types of attacks that you'll see launched against an AWS environment can pretty neatly fit into one of these three families. You'll see resource saturation, which is your garden variety DDoS, one person or a host of people trying to saturate resources that you've dedicated to an environment. Really a good way of mitigating this is to auto-scale everything you can. A lot of things in AWS are kind of auto-scaling by default. There's usually some limits that it won't scale beyond so that it doesn't start billing crazy amounts. I guess most people prefer, rightfully so, that their service starts degrading a little bit before they find themselves in a position where they owe AWS hundreds of thousands or millions of dollars. But you can request AWS to increase those throttles. And instead of using just straight EC2 instances to back your service, you can use auto-scaling groups, which will respond pretty, I guess, elastically is the term they like to use, elastically to most types of DDoS. Host compromise, this is kind of your normal, there's a vulnerability, attacker scans, finds it, and then gets some presence on your host that you would rather they didn't have. That can lead to command injection, remote file inclusion, local file inclusion, whatever kind of vulnerability is there, that's just your host compromise family. And then there's account compromise, where a malicious actor is able to get API keys to your account to make calls to AWS that will affect things within your account, or even just collect information within your account. So this could be an IAM takeover. There are some situations where this has been very, very impactful to the compromised organization. So the first pivoting approach, or pivoting method that I'll talk about is going from the control plane to the data plane. So this is where I, as an attacker, have IAM API keys to make calls on somebody else's behalf. So I may have found these in like a Git repository or in some documentation or in an archive for tooling somewhere. Like I said, there's a lot of places these credentials could be stored, and there's a lot of places that these credentials can get out into the wild. So let's say you're doing an assessment and you find these credentials. What do you do with them? So your goal is probably going to be to learn what the account that these API keys belong to is used for, and to get onto the instances or pull information off of the instances to get more information to prove you were there and this is a big bug and the bug bounty people or whoever's running the bug bounty program should give you lots of money for it. So the first thing you want to do is get the caller identity. STS, the simple token service, has a nice call called get caller identity. If you set up a client with either Boto 3 or the CLI, you can do that STS, get caller identity, and it will respond with the account ID, the username of the user or role that you're using, and the ARN, which is the Amazon resource number. It's the unique identifier for your user. Once you have that, you want to start finding what permissions you have. So this is where things could get difficult. If the product or the account administrators that you're working with here are really good about implementing least privilege, you may start making some of these calls and you'll get access denied. That's very possible that could happen. Assuming you don't run into that, you can list your attached users policies. So any policies that have been attached directly to your user. You can look for groups that you're a member of, get policies attached to those groups. So there you should have an idea of what kinds of things you can call. You'll need to dig through those IAM policies, which can be kind of cryptic, but they'll give you an idea of what services are in use and what things you can do. Often people are pretty lazy, and they'll use the AWS managed policies. Those are policies that AWS creates and updates. So for things like read-only access or S3 access, you'll be able to just really quickly get an idea of, oh, I'm this user and I have access to do EC2 things or S3 things or whatever. Next thing you'll want to know is what regions are being used. One approach could be to iterate through every single AWS region and call list resources on every single client. That's pretty messy and it's very loud. You're more likely to attract attention of a SOC or anybody that's watching the logs coming out of this account. A little bit more discreet way of doing it is to look at global services that have regional ties. So there are things like S3, which is technically a global service, but the S3 buckets actually do reside within a region. So if you make an S3 call saying list buckets, it'll give you a list of all the buckets in the account, regardless of what region they're in, and it will also tell you the region that those S3 buckets are placed in. So if you see a handful of S3 buckets in US East 2 or whatever, you can then start trying to list your instances or look for other resources in that region instead of going pretty haphazardly and casting a wide net trying to look at all regions everywhere. I think at this point there's like 14 or 15 different regions. So you could script that all, but again, it would take some time and it'd be noisy. Another way of doing it would be to look at Trusted Advisor checks. So Trusted Advisor is another one of those global services. It's actually grouped within the support set of APIs. And Trusted Advisor will escalate findings for resources regardless of the region they're in. So if you can list Trusted Advisor check results, it will give you, like, this check responded with green. The resource was configured okay. This was the resource ID in ARN. So you'll know, okay, well, there's a resource in APAC, or what's it called? Like AP Northeast 2 that was green, but I know there's something over there. So back to the situation where the team has been really effective and thorough, and they've whittled it down so you only have, well, you don't have any IAM list permissions. You can try to brute force things. You can do it yourself to try and just make the calls. Some of the calls have dry run flags so that you can try to do it, see if you get authorization failures without actually modifying any resources. So that could be a little safer. You're less likely to break something if the call actually works. Or there's a tool called Nimbostratus, written by a guy named Andres Riancho. I think he released this at Black Hat about 2 or 3 years ago, called Nimbostratus. It has a handful of these common APIs that it will attempt as a dry run, and then it will report back to you which of the calls it was able to succeed and which ones it didn't. So we now know what our permissions are, and we want some data off of an instance. So we want to get to the goodies that are on the host. So the first thing you want to do is figure out what instances you want to get a more thorough look at. Tags are really useful. Most account administrators will tag their instances with something useful so that they know what that instance is used for. If you don't do that, you end up with a list of 20 or 30 or 400 instances, and you don't know what's supposed to be running or what's not supposed to be running, what the purposes of each instance are. So most of the time you'll see tags on these instances, including the name and whatever other metadata the account owners wanted to put on there, which is also useful for getting context as an attacker. So you can start describing tags on these clients and find something that grabs your attention. You might, let's say you find, for example, like a configuration control, a configuration manager master, like an Ansible or a Salt master. So you now have the instance, like you've targeted an instance, you have access to be able to make calls against it from the AWS APIs, but you don't have any access onto the host itself. You can't like shuffle around public keys that are on the host or inject a new private key so you can SSH to it. So you're kind of stuck here. One way that I found that you can get information off of these hosts are by taking a snapshot. So you can take a snapshot of an EBS volume attached to an EC2 instance. You can do this while the instance is running, so there's no need to shut it down, snapshot it, pull it out. You can just take it without causing any kind of outages that might be noticed. And then you can share that snapshot to a different AWS account that you own. There are a lot of accounts, a lot of snapshots that have been shared globally. This is a pretty commonly recognized security issue that people will take backup security snapshots, and then instead of trying to share them just to their backup account, they'll share them to everybody. There's been a handful of situations that you can read about where people have had SSH keys or certificates or all kinds of stuff on these shared snapshots that then anybody can create a volume off of and then kick an instance off of. Once you have the snapshot, like I as an attacker, I shared the snapshot to my other account, I can turn that snapshot into a volume and then either mount that to an already running instance, or I can boot a new instance off of that, replacing the public key in that home directory so I can SSH in and work with it interactively. It's not quite as good maybe as having access to the original host, because I couldn't like put a keylogger on here and get information from somebody else that could log on. You'll lose some of the context. So if this host is communicating with other hosts, you can't run a packet capture and pull together those interactions. But for things like like a certificate, you could probably pull that. For things like Ansible runbooks or salt states that might be placing configuration files out on other parts of the cluster, you'd be able to gather that all and either get credentials or like database credentials that you could then go back to the original account and escalate through that way. Who's heard of code spaces? No hands for code spaces. Oh, there's a couple. They're kind of infamous when it comes to AWS security. The reason for that is about 2 years ago, they lost access of, well, they had some API keys to AWS that got out into the wild. An attacker found those, logged in, created backdoor users, created ransom notes, and basically said, give me however much money, or I'm going to torch and burn your entire infrastructure to the ground. So about 12 hours went by. I guess there were some hostage negotiations or something that happened, and the attackers weren't happy, and they did burn everything to the ground. That company was shut down basically overnight. In the write-up that they made about it, there was one interesting statement that I saw. They said, it became clear that so far no machine access had been achieved due to the intruder not having our private keys. Whoever wrote this write-up was probably not familiar with this process of pulling the EBS snapshots out of the account, sharing it somewhere else, and then reattaching it to a new instance. As soon as you have the ability to create a snapshot and to share that snapshot, your machine data you can pretty much consider compromised. So going the other way around, going from the data plane to the control plane. In this situation, we are looking for credentials. There's a handful of ways that you can look for those. Like we said before, there's those 5 different places where credentials commonly hide. If you have remote file inclusion on an EC2 job, like on a web server that's running on EC2, you can leverage that RFI to basically proxy requests to the IAM, well, to the metadata service. This will let you pull those STS credentials, put them into a CLI configuration, a CLI credentials file, and you've got your control plane access. Sometimes people won't use the role. Sometimes they will just put the credentials straight into user data, which is basically the script that runs on these AWS instances when they are kicked. And instead of attaching a role to it, they'll just say echo in this script, in this user data script, say echo this credential into home.aws credentials. So if you can pull the user data, you may be able to find control plane credentials. If you have local file inclusion, you can attempt to retrieve that AWS credentials file. And one attack that I haven't heard about yet, but I'm expecting will probably happen some point, is server-side JavaScript injection, where you are attempting to retrieve the environment of the running process. I think this is especially interesting because this will affect even serverless deployments, where something like Lambda has those secrets stored in the environment variables. If you can do JavaScript injection into that, well, it might not be JavaScript. It could also be Python or Ruby or whatever language the Lambda function is written in. If you can get it to return its environment, you can then assume that role and make calls in the context of that Lambda user. Most of the time, these roles do not have conditions tied around them. So once the API keys in the session token are out, those can be used from anywhere. Those can be used from your desktop. They can be used from another EC2 instance. Once they're gone, they're kind of gone until they're expired. So a few other services that are commonly misused are S3. A lot of the incidents that you read about in the news lately have been misconfigured S3 access, partially because they are pretty complicated. There's not just a one button saying, hey, make this private so that only I can read it. There's a combination of permissions that you have to review. There's an access control list. There's a bucket policy. There's a website configuration. And if any of one of these has some kind of public grants, it's possible that an unauthenticated party may be able to pull resources, keys, or more generically, just files from your S3 bucket. Another part of the policy that is confusing is the authenticated users principle. Most people probably would think, looking at it, I know I certainly did, that authenticated users means anybody in my AWS account. That is not what authenticated users mean. Authenticated users means anybody that can make a call against AWS for any AWS account. So if I have grants to authenticated users, That means that if somebody else has a credit card and a phone number, they can create another AWS account, and then they are considered an authenticated user for my IAM role. Next is references to dynamic and deprecated resources. This is one that's bitten a couple people too. If there was a research paper done by Bishop Fox a while ago where they would create an AWS account, allocate EIPs, which are elastic IP addresses, and then they would do a reverse DNS lookup on those IPs to see what domains had been previously associated with them. Once they have that, they could set up a website on that EIP, and they could make a certificate request against something like Let's Encrypt to get a valid certificate for the previous owner of that IP address. They could then start funneling traffic there, or if the original owner of that IP address had application traffic still going there, they could present they could present whatever content they wanted to the bucket owner, or the EIP owner, or to the customers that are using that application. Same thing can be done with an S3 bucket here. If you have static content sitting in an S3 bucket, which your application uses, you delete that S3 bucket. A malicious person could recreate that S3 bucket and then host content that your application would direct your customers to. One recommendation for this is when you are no longer using an EIP or a bucket, instead of deleting it or disassociating it, just purge it out, remove all the content, remove all the permissions, and just let it sit there. You're not going to get billed for an empty S3 bucket that has no put object or get object or no object retrievals or pushes. And it's a good way of just making sure that's not abused in the future. AWS has a handful of good services for catching some of these things. Trusted Advisor is pretty dang good. Most of the AWS compromises that you'll see, if you look at the AWS Trusted Advisor console, there's a good chance that there is a check that would have mitigated that. It's kind of a fun game you can play, that when you read about an AWS compromise, see if you can find which check ID they were ignoring in their Trusted Advisor console that led to their breach. Almost every time, they will have been ignoring one of them. Abuse reports, if your instances start doing SSH scanning or showing any kind of not any kind, but a couple of very specific types of network behavior, they'll contact you via email, or they'll open an event in your personal health dashboard, which is kind of their support channel, to let you know that this instance is suspected to be compromised. Another really cool method they do is they review Git commits. So if you have a tool that you've downloaded that interacts with the AWS APIs, and you put a credentials file there next to it, and then you commit it to some fork that you've made in your GitHub public repo, AWS scans that. It will identify the key that it's an AWS key. They will internally do a lookup to see what account ID that API key is tied to, and they will email you. I did an experiment with a coworker a couple of months ago where we tested this, and within about 40 minutes of the time we pushed these keys, a key to Git, we had emails from support. And it turns out they kind of badger you on that. I wanted to leave it open for a couple days to see what attackers would do, what types of calls they would make if they had these permissions. Well, not permissions, but if they had the keys. It was there for 4 days. Nobody picked it up. I guess attackers kind of step up their game there. Other defensive measures, enable CloudTrail. It's cheap, it's easy, and it is by far the most useful piece of information that you can use when trying to figure out what an attacker did when they had access into your account. Another good idea is to send those logs to a different AWS account. That makes it so that if the logs are exported somewhere else and your account is compromised, they can't go in there and start removing their logs. They can stop future logging, potentially, but they cannot delete the logs of previously taken actions. If they do end up, excuse me. If an attacker does try to stop logging, they may succeed, but the last event that will be delivered by CloudTrail is that stop logging call. So that's a really good call to put some alerting around, that if you see somebody make a call to stop logging on CloudTrail, whether it succeeds or fails, that's a pretty high confidence indicator that somebody's trying to do something sketchy. Roles are great. Use roles wherever you can. rather than permanent credentials. They're easier to maintain. You don't have to rotate them. Make sure you use least privilege on those roles. Never ever create root API credentials. There's really not a reason for it. If you create an IAM, like a privileged IAM user, give them power user, use that as your pseudo root API credentials if you need to. If you lose your root API keys, it's a lot harder for support to help you out than if you just lose like some other IAM user's API credentials. And again, don't release EAPs or bucket names. So, talked about STS credentials and those being available on hosts. Usually that's considered a secure way of putting that down. Like you attach the permissions to an IAM role, you put the IAM role on the instance, you don't have to worry about credentials, and nobody else can use it. I wrote a tool, excuse me. I wrote a tool which I intended on demoing today, but I'm not going to because I didn't quite have time and I didn't dare make the necessary sacrifices to the demo gods. If you have a script that's running on that EC2 instance that has an IAM role, usually regardless of the user it's running as, it can pull that metadata service and get those credentials. So I wrote a small Python script that you can run on a EC2 instance that you've compromised, and then a Flask server that you can run on a control node that you have in either some other AWS account or in your basement or wherever. And as those credentials change on the EC2 instance, as the STS credentials expire and are rotated in the metadata service, this script will pick those up out of metadata, they will send them to your Flask service, and that Flask service will rewrite your credentials file to either create or update that role profile. That makes it so that you can look in your credentials file, see what roles you've been given access to, what roles you've been given keys for, and then you can specify those profiles to make S3, to make whatever calls you want to against AWS APIs. So that gets around the expiration that STS credentials have. As long as that file, that script is running on the compromised EC2 instance, your credentials file on your host will continue to have access to the AWS APIs. So how do you mitigate that? There's a pretty cool IP tables flag that you can run. I didn't know this until just a little while ago, but you can say on IP tables to only allow processes running as specific UIDs access, like you can write rules in IP tables that have UIDs as a determining factor. So right here you can say only allow access to the metadata service if the UID of the running process is root. This makes it so that if you have a web application that is compromised and is hopefully running it as HTTPD or as Apache, and an attacker finds a remote file inclusion vulnerability in it, even though it's able to like proxy requests, and you might be able to do RFI to a host, like something up back on the internet, you could not include that metadata that would allow the attacker to exfiltrate the STS credentials. I don't know that many people do this. There's a little bit of documentation around how to set it up. It's basically that line, but it's a good idea if you're looking for good ways to lock down access to your EC2. So it's 4:40, we still got more time. Anybody in here do scanning as part of their security role? Nmap scanning, vulnerability scanning, Nessus, Nexpose, whatever you got. Got a handful of people. That was one of my first tasks as a security engineer. And it's kind of been an interest of mine since then. I love being able to like spin things up, collect information, and then provide it back, do pretty graphs, whatever, help people fix their stuff quickly. So let's put ourselves in a scenario where a new 0-day just dropped. Instead of heartbleed or whatever, we've got nosebleed. And you can determine your exposure via a HTTP request to the nose method. And if it responds with some particular header, like insufficient humidity or whatever, then you know it's vulnerable. So there's an nmap NSE that already has this. Like you can call http headers.nse to retrieve the HTTP response headers from a given web server. Well, now let's say you have 100,000 public IP addresses that you need to chew through. So there are some tools that are really good at doing very rapid scanning. Mass scan is one that does kind of asynchronous scanning. It'll just spew out packets with the same TCP source IP or source port and the same acknowledgement number and everything. So it basically just replays the exact same packet to a bunch of different destination IPs. But it takes a little bit more work to get something like header information back. And your ISP is probably going to be pretty ticked at you if you do it for very long. So I turned to Lambda. Lambda for me has kind of been like you know, the hammer and nail. When you're a hammer, everything looks like a nail. I started working with Lambda about, I don't know, 14, 15 months ago. And since then, every time I see a problem, I try to fix it with Lambda. So Lambda has supported languages, Python, Node.js, Java, lots of them. I use Python for pretty much everything. And Python has an nmap library, so great. I can use Lambda, I can call nmap, I can pass the NSE to it, and then nmap will give back to me what the responded headers were. Well, the problem with that is that Python requires nmap to be installed. The Python library is basically just a wrapper for that binary. Excuse me, yeah, the library is a wrapper for the binary. So when you call nmap within Python, it shells out to nmap, passes your arguments, pulls back the response, does a little bit of formatting and puts it in JSON and stuff, and then hands it back to you. So I had to figure out a way of getting nmap into a Lambda function, which required understanding a little bit more about how Lambda was working. The way Lambda works is it takes your script and potentially a deployment package, which is your script with some other dependencies wrapped up into a zip file, and it puts it into var task in an ECS container. So basically, AWS has a ginormous Elastic Container Service cluster running, and when you request a Lambda function to be run, it allocates one of these containers, it pushes your, your deployment package into var task, and then it calls var task and whatever the name of your function is. So that's pretty flexible in that anything you put into that deployment package, anything you put into that zip file will also be pulled into that container. So what you can do is you can compile nmap for Amazon Linux, which is the instance type that ECS and Lambda runs on, and you can configure that and compile it into a Python virtual environment, zip that up, and put it into Lambda. One thing that you need to do to make sure that the Python library will still work is modify the path. So you can call, what is that here? Yeah, os.addPath vartask bin, assuming you compiled and built nmap into the bin directory of your virtual environment. And then you can use nmap just like normal. So you can call it with your tac script. You still have to, if you're calling NSEs, you still need to take into consideration the location where those NSEs will be in the container. So instead of saying just like nmap http headers.nse, you have to give it the full path of vartask share nmap scripts or wherever you ended up putting them in your deployment package. You can then use Python and Lambda to parallelize your scanning like crazy. Anybody have a guess at how long it would take to scan 100,000 IPs with an NSE that takes 5 seconds to execute? It's not rhetorical. Like, I want to hear a guess. A long time, someone said? That was a boring answer. Fail, Brendan. It takes about 3.5 minutes. By default, there's a Lambda execution limit of 1,000 concurrent executions. You can contact support, and without too much arguing, they'll up that to about 3,000. So you can scan 3,000 IPs at a time, go through 100,000 IPs in 34 batches, seconds per batch, 3.5 minutes to do your nmap scan across 100,000 hosts. Anybody have a guess at how much that would cost? A couple bucks, 50 bucks? Yep, that's pretty close. Not 50, a couple. It costs about $1.25. Lambda is billed in megabyte seconds. So depending on how much memory you assign to these functions, and depending on how long they run, that will go up or down. For most nmap stuff, I can't think of a reason why an NSE would need more than 128 megs of RAM. maybe there is, but I can't think of one. So I assign 128 megs to the function, and you're billing at 0.1, 2, 3, 4, 5, 6, so 0.000000208 cents per 100 milliseconds that the functions run. So 6 million decaseconds bills to about $1.25. So I don't know. If your manager says, "Hey, I need this awareness of our nosebleed exposure across all of our huge external IP space," you can tell them it'll cost you $50, and then you can take the rest of it and get something nice on Amazon. Here's a handful of useful resources. IAM permissions, Boto 3 API docs. There's a couple really good talks at previous reInvent sessions. Those are both from AWS employees that really know their stuff. There's a talk specifically about pivoting in Amazon clouds by the Andres Ariancho, who released that Nimbostratus tool. A little bit of a guide to creating Lambda functions. Flaws Challenge, which is put together by a presenter that spoke here on Tuesday, Scott Pippin. It's an excellent tool. It will give you challenges to walk through and try a lot of these different attack and pivoting approaches that I went through today. Yeah, it's a fantastic tool. So that's all I've got. Anybody have any questions? No questions. All right, well, I'll be here for a couple minutes. If you want to talk or if you have questions about anything, feel free to come up and chat to me. Thank you.